Hello, my name is Alex Landis, and today we'll be going over short field takeoffs and climb. This maneuver would be primarily catered towards a private student as a first introduction, and then more commonly practiced by a commercial student, right? So for both of the private and commercial student, they are required by the ACS for their check rides respectively. But this is definitely a maneuver more so that's important to know for safety primarily, right? This is why the FAA requires us to do these things. So for the introduction of what a short field takeoff and climb is and why we use it, it's pretty self-explanatory, right? So as the name indicates, right, it's designed for a scenario where the runway is shorter than we would like. We like it to be for safe operations, right? So as a general rule of thumb, for takeoff and landing operations, right, we're going to use our takeoff and landing performance charts, which are on the POH, and we'll talk about here in a moment. But for a general rule of thumb, right, it depends on the person, how comfortable they are with the aircraft, where they are in their training, all sorts of things. Some people like to say whatever the performance data that is indicated in the POH for those specific operations, that we will do double that distance is something that we consider safe for takeoff or landing, right? Some people like to use a figure of 1.5 times those numbers, right? So whatever the case may be, this is an operation where it's shorter than where we'd like it to be, regardless of where your minimums are. This is designated for a short field takeoff, right? So what would be a scenario where we take off from a short field? So at Lafayette, we kind of have the luxury of having a field with long runways, right? So actually, as a matter of fact, I know a pilot from Southwest Airlines, and he actually told me that runway 28 here at Lafayette is actually longer than the runways at Midway, which blew my mind. But regardless, we are blessed at Purdue to have plenty of runway length for all of our operations, right? This is a maneuver for non-standard for us people at Purdue, right? So a short field can be indicated by not just a short runway, but right, maybe we have an obstacle at the end of the runway, right? Let's say we have a tree, right? Our tree is at the end of the runway, and it's a short runway, right? So we're going to need to be able to, in this distance, not only take off, right? Because then we took off here, got a big explosion, right? And we'd hurt ourselves or hurt somebody, right? Or kill ourselves potentially. I know there's a video that I would show in this scenario where there was a tragic accident a couple of years ago where there was an individual who actually wasn't calculating for the distance they needed to take off. And there's an actual footage of them not being able to climb out fast enough to do density, altitude, and all of these things. And they ended up killing themselves. And there are other scenarios where I remember I was in class for CFI ground, and they talked about an individual who Mr. Dillman gave a check ride to, and he had he had his own plane, right? And he was going to fly his girlfriend out to a specific lake to propose to her, right? So he flew her out, didn't really recognize, so it was a short runway, they had taken off the night before, he had a slight tailwind, he didn't have enough room to clear the obstacle at the end of the runway, and it tragically resulted in the passing of not only him, but his to-be potentially fiance as well. So in order to avoid scenarios like that, this is why we do this sort of training. So definitely would emphasize this to a student. We're not just doing this to make you do a maneuver or just to pass ACS standards, but this really could be difference between life and death one day if you decided to take off from a short field, right? So, so for this maneuver, we obviously want to use all this available runway to not just take off, but to clear this obstacle, right? So how do we do this, someone might ask. So to set up for a short field takeoff, first of all, you always want to plan if possible, beforehand, or you definitely should plan in normal operations before taking off, right? So I don't have my iPad with me, unfortunately, but on my phone I have the takeoff performance for the Archer and the POH, right? So we have this takeoff performance, right? Let me lock my screen. We have this takeoff performance, right? You can see, gosh dang it. Sorry, technical difficulties. Get back to that page. So we have this takeoff ground, right? And these will give us all of the data that we need for flight, for taking off from a short field, right? But what you can see is this is actually not the data that we would use for a short field takeoff, right? And why would this be? And for a private applicant, they might not necessarily know this because we've never covered a short field takeoff. But for a commercial applicant, I would definitely hope that they would realize that this is for a flaps up takeoff. As you can see right there, flaps up. And what we know as a commercial student or commercial applicant for sure is that for a soft field takeoff, we use 25 degrees of flaps in the Archer, right? So we use the 2 notches of flaps in the Archer in order to take off. So for this data, we need to recognize this is not the data that we'd be using. Rather, we'd be using this data, right? Which is the flaps 25 degrees data, right? So in this scenario, for a private applicant, I'll definitely walk this through because they might not have ever seen this chart before, right? So using this as a reference, I'll go on the board, right? So we have this chart, right, and it gives us our outside air temperature, our OAT, right here. And it gives us these different pressures, right, on this chart, and it's got this box, right? And then it falls somewhere in here, right? We got sea level, right? We got 2,000 feet. We got 4,000 feet, and so on, right? So at Lafayette, typically, right, our field elevation is 606 feet, right? But how do we, for a private applicant, again, they might not know this, for a commercial applicant, they definitely should. How do we adjust for this pressure altitude, right? This pressure altitude. Well, we know that on a standard day, right, the altimeter should indicate 29.92, right? So that's standard, right? So how we adjust for non-standard pressure altitude, right, is we take this 2992 and let's say we have a day of high density altitude, right? So it's, let's say it's 30.17, let's say, right, is the density altitude. So you take that number and you would subtract it from the 2992, right, which is standard for the day. So let me I am not great at mental math, and I don't want to embarrass myself and mess up in front of my student or people for sure. So we take this calculation and go 29.92, right? And we'd subtract 30.17 from that. We'd be left with negative 0.25. That just happened to work out. That's great. So negative 0.25, right? And then what we're going to do is we're going to multiply this by 1,000, 1, 2, 3, right? And for 1,000, you just go 1, 2, 3 decimal places, which then equals negative 250 feet, right? So that's how we get this number. And from this, we'll take our 606, which is our field elevation right here, right? We'll subtract 250 from it, 250. And then we're left with 356. This is our pressure altitude right here, right? This is adjusted for the altimeter setting, right? So once we get this, we'll know that for following this line, we have our outside air temperatures here, right? So let's say on our chart it says, let me pull it up really quick. On the chart it says we have 10 degrees here, right? And this is all in Celsius, so 10 degrees Celsius. Let's say we're following the 10 degrees Celsius line. So 10, you have, it's an increment of 10, so you have 0 here, you have 20 here, and these are all going up, right? These all have their own lines, but you're following 10 degrees Celsius for that day, right? And following this, you're at around, so we're adjusting for this 356 right here, right? So we'd fall maybe right around in here. Follow this line over this way in the chart, right? And as you're going across the chart, then you're going to come to your weight, right? So you come to your weight, and we're going to, hopefully, we've done a weight and balance lesson at this point already, and we're going to calculate our weight, and they have these little reference lines, right? These little reference lines that we're going to follow. We're going to follow them to, so wherever we start at, so we're going to follow this line, and then they're going to have the weights right here. They're going to have 2,500, 2,400, 2,300, right? We're going to, and say, let's say we're at 2,300, right? So we're going to follow where this line right here intersects this line right here. So we're going to come here, come straight across, right? And then we're going to come to our wind components, right? Let me get this guy out of the way really quick. We're going to come to our wind components. In our wind components, we're going to have another line that we're going to follow, right? So wind components, we're going to have a line here, and then we're going to have our wind components like this, right? And let's say on that day, this is measured as a headwind, right? We always want to take off and do a headwind anyway, so this is the first indication of how also we walk through a short field takeoff, right? If we're going to want the most allowable runway, we're obviously going to want to take off into a headwind, right? So for this, we'll say we'll have a 5-knot headwind. These are all 5-knot headwind increments. And we're going to follow this line down to 5 knots, right? So we have 0 here, 5 here, 10 here. We're going to follow down to this 5 knots, right? We're going to follow this line down to 5 knots. And we're going to follow all the way across. And this is going to give us our landing distance that we're required. And let's say we followed across, and it gives us 1,000s here, let's say, right? 1,500s here. We're going to end up somewhere between these. So let's say we end up at 1,250. So 1,250, right? That would be our landing distance necessary, our runway distance necessary to take off from the field. So these are definitely things in the short field takeoff scenario that we're going to run beforehand. So let's say we would have to have this 1,250, 1,250 feet to take off, right? And we end up only having a 1,000-foot runway. I don't know why it would necessarily ever be that short, but to say we have a scenario where that would be the case, we would obviously not run this short field takeoff scenario under those conditions, right? So we're going to follow all these steps to determine beforehand the distance we're going to need to take off given the short field flaps 25 degrees operations that we will be running, right? So back to the scenario, right, where we're taking off, we got the short field, we determine, okay, we have enough distance, and we have this obstacle at the end of the runway, right? We have enough distance to take off and climb out, right? So we're not going to, so in normal operations, right, we're going to take out and climb out on VY. But look what happens. If this is VY, we won't be able to clear this obstacle in some cases, all right? And so we want to have as much separation from this obstacle as we can, right? So when we take off, we're going to want to take off at Vx, right? We got Vx, we got Vy. So Vy is the best rate of climb, which is what under normal operations we will do. And the Archer, Vy is at 76 knots in the Archer, and it's at 64 knots for Vx in the Archer, right? So those are things we need to consider. But first, how do we maintain as much runway length as possible? How do we use it as efficiently as possible, right? So when we line up for the runway, right, we already talked about we're going to select 2 notches of flaps in the Archer at 25 degrees of flaps, right? And we're going to use all available runway. And the thing about all available runway is usually we just take off in front of the displaced threshold, right? In front of the runway threshold bar, we would take off under normal operations. But under short field operations, we can use that displaced threshold because we're using all the runway possible to take off, right? So we're going to line up. We're going to be as far back on this displaced threshold as we can be, right? We're going to set our brake, And then we're going to already, if we don't already have them, set our flaps to 25 degrees, 2 notches of flaps in the Archer, right? Set that brake, we're going to run the power up, right? We're going to run full power, holding that brake, and once we get to our maximum engine performance, we're going to release that brake, right? And we're going to go down the runway. We're going to rotate at 55 knots, right? And we're going to pitch for the 64 knots at VX right here, right? Again, this is going to give us our best angle of climb. So if you look here, we're going to have a better angle than we do here, right? So we're getting this best angle of climb to clear this obstacle, right? And then once we clear said obstacle, right, we can pitch, we can gradually let out our flaps, and we can pitch for the 76, this VY, and climb out, right? So we can go from climbing here, once we clear the obstacle, we take our flaps out, maybe 1, 2, and then we can pitch out for this VY, right? And that's kind of how a short field takeoff goes. We went over the calculations. We went over the amount of runway we can use. We went over why we do it. We went over VX and VY and the differences between the two, and why we use them and what we use in a short field operation, right? And we went over how to recover from that attitude in the process beyond that. And then again, once we're climbing out at VY and we're clear the obstacle, we're clear the field, all those things, we'll pull out our checklist. We'll do our when we get to cruise, we'll do our climb checklist, right? And then once you get to cruise altitude, we'll do our cruise checklist, right? So that is a summary, and that is the basis of a short field takeoff and why we do it. And that is all that I have. For a student, we would obviously go out and perform this maneuver. I would obviously reference them beforehand so they get a general understanding coming into it. The Airplane Flying Handbook, Chapter 5, I believe. And then this would be a lesson. So thank you so much for your time. I hope you enjoyed. See you next time.